petrified wood in the area. In central Washington, we got loads of it. Not everybody has it. There's whole states that don't have any petrified wood at all. We got quite a bit. Why? And what does that petrified wood tell us about our history? Does it tell us that our climate was different? By looking at the different kinds of trees that we have in that petrified forest, can we reconstruct some details about central Washington 15 million years ago? Who were the first people that were studying those logs? Is there anybody today studying those logs? Things like that. Tell you what, let's start by doing this. Let's make a little quick sketch map and just try to get a few things on the board, okay? So this is going to be crude. This is going to be a sketch map. All right. That's the Columbia River. This is a map now, okay? Here's the Yakima River. Okay? With me so far? Here is Interstate 90. So we've got Ellensburg, we've got Vantage, we've got Moses Lake. Okay? Got your bearings? Yakima, Washington. Sunnyside. A little town down here on this is the Columbia River Gorge all the way down here. A little town of Roosevelt. Probably never heard of it. Down at the Columbia River Gorge. Okay. Where can I go find petrified logs? Where have people been looking for petrified logs over the last 100 years? The obvious answer is at what is now Ginkgo Petrified Forest State Park. That's here, right? So this is going to be a treasure map. Let's put a bunch of X's. So there's an X at Vantage. That's an obvious place to find petrified logs. They're loose on the ground, but more commonly they are buried. They are in the bedrock layers. So you got to work to get these things out. And it's not just logs. It's branches. It's twigs. It's cones occasionally. It's leaf, the whole thing. Okay? Good. So Vantage is the obvious answer, but there are more places than that. I suppose the common visitor to Washington says, oh yeah, there's the side for the Petrified Wood State Park, so that must be the only spot. No, no, no. Many of you know there's plenty of other places to find the wood. Where? Well, we could go up on top of Saddle Mountain. We can go just south of Othello or east of Mattawa, that big, beautiful ridge. Lots of petrified wood up there, Saddle Mountains. We can go in the Yakima River Canyon, Umtanum at the footbridge. Petrified wood there. Further down in the canyon, Yakima Ridge, petrified log. There's petrified logs in this valley, Kittitas Valley, up in Badger Pocket, southeastern corner of the valley. Beautiful petrified logs that were pulled out of the Menashtash Ridge area, what used to be called Squaw Creek, a location. Sunnyside, outside of Sunnyside, there's a gap, a ridge near the Rattlesnake Hills. Good logs there. And this place I'm mentioning down at the Columbia River Gorge, near this little place called Roosevelt. So I'm not just pulling these locations out of my head. I have wood to share with you tonight, petrified wood, and some photos as well. And the samples that have been donated to our department or that I have read about in these journals are over and over and over again coming from these locations that I just threw on the board. You might have your favorite spot that's not, but let's stick with these guys right here, okay? So we've got a lot of locations to find these petrified wood, these petrified logs in the hills. Okay. Are they all from the same forest? That's a decent question. Are all these logs from the same forest, and are all the logs the same kind of wood? You probably know the answer to that. There's an incredible variety of species, of trees, of wood types in these petrified log collections. And even at each of these X's, there's a variety. It's not like you got oak here, and you got redwood here, and you got ginkgo here. It's an incredible variety, and the ginkgo tree is a rarity. So when you hear Ginkgo Petrified Forest, please don't think a dense forest of ginkgo trees. That nobody's trying to peddle that. There were some ginkgo logs found, and they are prized, but they are a minority in this collection of wood. But what we really want to work on is, do we have one master layer of petrified wood that all these locations are coming from? I don't know how you feel right now. Is it an obvious yes? Is it an obvious no? Let's let that sit there for a second. I'm going to get rid of the Saddle Mountains. I'm going to move the Saddle Mountains. Let's do that. I'm going to move the Saddle Mountains there, okay? So now I'm going to do not a map, but I'm going to do a cross-section. I'm going to do a side view, okay? And introduce a couple of other concepts. You hearing me okay in the back there? That's good to know. Pregnant pause here. Let's just let the silence linger. All right. Do you know that the bedrock layers pretty much dominating eastern Washington are one kind of rock for the most part? Basalt. B-A-S-A-L-T, high school students. Basalt. Lava. Lava flows, one after another. More than 300 lava flows stacked one on top of another, generally. More than 2 miles of basalt, bottom to top. And the petrified logs are coming from this stack of lavas. Now, first off, that's a surprise, isn't it? Lava's, it's Hawaiian-like lava coming in with incredible temperatures. How could anything survive lava flows? And we're pulling petrified logs out of the lava. That's true. The logs are coming right from the basalt lavas. That's unusual. We're not the only place in the world that has petrified wood. You know that, right? There's Petrified Forest National Park in Arizona. You get on the internet and I just did this last night, you find locations all over the world. But it is pretty unusual to be pulling petrified wood out of basalt lava. That is a rarity. So we've got to come to terms with that and understand what that means for us. But back to the story and the question we're trying to work on. Who remembers the question? What's the main question we're trying to figure out? Good, right. Perfectly said. Are all these logs coming from the same forest, from the same time? Okay. I'll cut to the chase. No. We have 3 buried forests, and we've given them names. The Ginkgo Petrified Forest, the title of this talk, is one of these horizons that yields hundreds and hundreds of logs. And they're coming from one lava flow. And let me put a bunch of X's in here for that. Okay, so X's are not only where we can find the treasure map, where we can find the logs, but we're going to have these X's be pulling these logs out of the Ginkgo Petrified Forest. Let me put a capital G for that. We have a date for that petrified forest, when those trees were alive. And just think of the concept here. We're talking about a relatively lush, dense forest in eastern Washington. Eastern Washington. Is there a dense forest out advantage today? There is not. So that tells us about how things were different 15.5 million years ago. I just gave you the date. Back of the room, you can't see that, sorry. 15.5 million years old for the Ginkgo Petrified Forest. And that's usually where things end in the discussion. You go to the State Park Visitor Center, good stuff down there, get that date, okay, there's one petrified forest. Most people, that's kind of where we stop. But I like the idea that there's more than one. There are 2 other major petrified forest layers, maybe not quite as rich as the Ginkgo Petrified Forest, but there is a SM, Saddle Mountains Petrified Forest layer. So let's put some more X's here. This is a forest that happened later, younger. You know geology, right? The layers at the bottom are the oldest, and we're working our way through geologic time. So the Saddle Mountains flow, Saddle Mountains Petrified Forest, 14.7 million years old. Not that much younger, really. It's in the ballpark of 15.5. And there's one more just below the Ginkgo. Another petrified forest layer, just below 15.5. Best date we've got, 15.8. Viumtanum. You know that name. the tandem petrified forest layer. So we've answered the question, but I want to do more with it. The question again was, are all these logs coming from the same time long ago? Many of them are coming from the Ginkgo Petrified Forest, but some of these spots are from the Saddle Mountain horizon, and some of these spots are from the tandem. I wrote this lecture over the weekend. I don't like looking at my notes, but I got to here, okay? So obviously, the Ginkgo Petrified Forest State Park is the 15.5 million year forest. But we get to the top of Menashtash Ridge at that Badger Pocket location, or the Upper Squaw Creek, or up one of the debris flows that Andy just reported before we started talking. Some of those slides that came down last summer, do you remember there was a little bit of stuff coming down on the canyon road going down the Yakima River Canyon? There's some, at least one newly exposed log up that draw. So that's a little tip. I stole your thunder, Andy. Maybe that was your story in a few minutes. Okay, great. Even at the Yakima Ridge, we've got our ginkgo horizon. More coming on that. But let's finish our work. Where are the Saddle Mountain logs coming from? The obvious answer is the Saddle Mountains, yes. But logs coming from the Sunnyside Gap, and many of the logs down in the Columbia River Gorge at Roosevelt are coming from that horizon. Older logs, younger logs, just a little bit younger than our ginkgo. If we go in the Yakima River Canyon, by the way, that's the topic next week if you want to come back. We're talking about not petrified wood, but talking about the formation of the Yakima River Canyon as a whole and some other things tied to it. Tandem. Okay, kind of interesting. Let me throw one more at you before we get rid of this. Let's think about the elevation of these locations. The elevation, how many feet above sea level for each of these spots? I jotted these down quickly. Vantage is roughly, I'm not even going to write them down, that's going to be too complicated. Vantage is at 700 feet above sea level. Top of Menashtash, 2,500 feet. Top of Yakima Ridge, which is where we also have ginkgo logs, 4,000 feet above sea level. Less than 1,000, 2,500 feet, 4,000 feet above sea level. But I thought they're all from the same horizon. How's that possible to have all these different elevations with these logs when we're saying they're all from the same horizon? What's the answer? Yes. The layers are not flat anymore. In some places, the layers are nice and flat. But in many places, including through this region, we have intense complications with the geometry of these layers. A basic law in geology says rock layers are originally horizontal, they're created flat, and for the most part this is true. We did have a nice stack with everybody nice and flat like in the Grand Canyon. But since that time, over the last 10 million years or so, there has been squeezing, plate tectonic compression to mess, I almost said something else, to mess with those horizontal layers. And I want to draw what that looks like for you in a second. But I want to give you a few more ideas about how you can find these layers. They're like old friends. Find these layers at radically different elevations. And have you tried to mentally figure how that's possible before I try to draw a couple of things? For instance, the main sediment horizon at Vantage is called the Vantage sediment. We're going to talk about it. The Vantage sediment is right beneath the Ginkgo Petrified forest. It's a light tan colored layer. And at Vantage, again, we're below 1,000 feet elevation. That same Vantage sediment horizon is at the top of Menashtash Ridge, 2,500 feet above sea level. As you drive I-82 to Yakima, as you go through the cut at the top of Menashtash, can you, in your mind, see a light-colored layer? It's almost vertical. It's not even flat. It's been flat and tipped. That's the idea we're talking about. I'll give you one more. The top of Saddle Mountain is 2,500 feet, 2,600 feet above sea level. Same guys down here are less than 400 feet elevation. Same idea. We need to warp and even break these originally flat layers to get that kind of geometry. So let me give you just a couple of made-up examples of that. You know, I teach geology of Washington every morning at 10 o'clock at campus, and it's usually a bunch of 19-year-olds that would like to be somewhere else. This is a luxury to have you all super attentive. I was going somewhere with that, but I can't remember what it was. Okay. Let me give you an idea then of what we're talking about with folding and faulting, and this will come in. This will be helpful to us next week if you come back, if you're able to come back with the formation of the Yakima River Canyon. Okay, great. So remember, we've got our flat layers that were created with one eruption after another. Good. Now, a nice simple concept, a cartoonish concept to explain the three main ridges between Ellensburg and Yakima. You take the freeway, you go over three ridges, right? A nice simple concept is that those originally flat-lying layers have been warped. They've been squeezed, they have warped, and where they warped up, it's an anticline, and we have Menashtash Ridge, or Northamptonham Ridge, or Southamptonham Ridge. And where they warp down, we have synclines, basins between those uplifted regions. That's a nice cartoonish idea. Why do we care about that tonight? Well, remember now, our logs, right? Our three horizons are getting caught up in that pattern. And so now here we've got our logs advantage. Oh, and our logs up on Menashtash. Oh, and our logs down at Rosa. But it's more complicated than that. We're experienced in geology, most of us. We're ready to handle something more closer to the truth than this. And Bentley and Powell and a few others spent a whole career mapping the details of these ridges. And they found faults. Not only folds, but they found faults. So let me try to just give you a simple picture of how a major fault that produces, yes, earthquakes, that's a topic for another day, how we can get our petrified logs higher than their brothers and sisters if we compress and not fold, but if we compress and fault. Here's our logs. Here's our logs. And we have taken half of the birthday cake and we have broken it from the rest of the cake. And with each magnitude 7 earthquake, we've shoved this thing up this fault ramp 10 feet, 20 feet, 15 feet every time we have a big earthquake. And we do have excellent exposures of faults like this between here and Yakima. If you really want the truth, and I'm not as gifted as I could be with drawing right now on the spot, we'd combine both of these. We'd have folding and we'd have faulting all at the same time to create a very complicated picture. But you get the idea. If you have the skills to visualize in 3 dimensions, you can find our petrified log layers, 3 of them. There's some minor layers, by the way, as well, but there's the 3 major ones that are cropping up at all these places in central Washington. There is a unifying theme. It's like you can connect the dots between these locations if you can visualize these stack of basalt lavas. We good? Okay, I'm not done yet with the chalkboard, but I'm getting close. About 5 more minutes of this, and then it's story time. That's where you come in. All right. Let's take one of these basalt flows now. We know that there's more than 300. Let's just take one and familiarize ourselves with a couple of specific features that are going to help us understand how this petrification takes place. You might be surprised, we're talking about petrified wood tonight, and I haven't talked about the logs yet and how we actually make them turn into stone, and when did that happen, and how long does that take? I'm going to let the video and some of the slides tell some of the story, but let's try a little bit of it here. So now we're down to one flow. Average thickness of one flow, one basalt lava flow, 100 feet. 100 feet. One flow. traveling some of the Grand Ronde flows 300 miles. So first of all, that's just a mind blower, right? How do you take 100 feet of molten lava and keep it molten 300 miles to cross the state? That's a whole nother discussion. There's models to explain that. But that's the scale of what we're talking about, and our petrified wood is part of that story. All right, great. So here's one flow coming in. Here's our 6-foot person. Okay? It's 1,200 degrees. It's super hot. It's orange. It's like Hawaiian lava. Almost always, forming at the top of this cooling basalt lava flow are gas bubbles that are going to get trapped in the cooling lava. So it's like a big stein of beautiful beer with all these bubbles rising to the top and getting out before you drink it. That's what's going on in a beautiful lava flow. There's lots of gases that are frantically trying to scream to the top, get out into the atmosphere, and escape this cooling lava. Well, this is a sad story. These guys don't quite make it. All right? They get trapped, the gas bubbles. These are called vesicles. So a vesicular top, or vesicles, are commonly found at the top of each of these flows. We don't care about those for petrified wood. We'll talk a lot about columns next week, because there's beautiful columns exposed in the Yakima River Canyon. Those columns form in these basalts, typically from the bottom up. I should have drawn the other way. That's next week. Let's not worry about those either. But the third major feature we do want to pause with. Pillows. Have you heard about these? Pillows sometimes, not always, sometimes form at the base of these monster basalt flows. Sometimes. Like if I still had my stack of 300, I'd only put pillows in, a handful. 20, 25 of them out of the 300. I'm guessing now. Okay. The pillows are circles. They're dark-colored circles. Whoa. Got a pillow hanging out into space here. Dark-colored circles. They're big. I mean, they're not these little tiny Swiss cheese-looking holes. I mean, they're the size of basketballs. They're dark-colored. And around each of these dark circles is kind of an orangish, greenish, crumbly, weird-looking background. But I would like to make sure that you realize we're pulling our logs. Remember we said the petrified logs are coming right out of the lava flows, which is hard to conceptualize. The logs are not coming out of the middle of the flow. Certainly the logs would have burned up if they're in the middle of a 100-foot thick section of super hot lava. The logs, remember there are X's, right? The logs are being pulled out of the pillow zone. Just down here at the base. Logs right out of the pillow zone. I'm trying to get you curious about what the pillows are telling us about the environment, and maybe you can already deduce a couple of things. But I want to tease you just a little bit. So no X's here in the middle, no X's here at the top, only X's down here in the pillow zone because something is protecting those logs. And the pillows are telling us about what is protecting those logs. But I'm not exaggerating now. You've got one flow with, let's say, 27 X's, and we might have a dozen different kinds of wood coming out of one lava flow at one location. And I'm talking about cypress wood right next to redwood, right next to ginkgo, right next to oak, right next to elm. Now, what is going on? Why do we have this crazy variety of wood coming from one little spot, maybe the width of this stage, where you can pull these logs out of this basalt flow? We're still working on that, but there's some models, and that's the last thing I want to do on the chalkboard here. Right below the Ginkgo Petrified forest layer, or the Saddle Mountain, or the Amtanum. I got throwing chalk again, you know. Is that sediment. If this is the ginkgo forest, if this is the one of the three layers that we're talking about, the vantage sediment is a 20-foot thick section of sediment below this base of this Ginkgo lava flow. There is work right now being done by some people in this audience with the details of this vantage sediment. And part of the reason for really revisiting the details of this vantage sediment, and these other sedimentary horizons, by the way, are this. Maybe if we can interpret these sedimentary units differently, it can help us explain why we've got this crazy variety. Can you think of a place where a cypress tree grows next to a spruce tree, grows right next to a redwood tree, grows right next to a ginkgo tree? I'm not an arborist, but I can't. And most of these logs look like they have been transported. They're beaten. They don't have lots of limbs coming off, fragile. They've been worked. And yes, they're petrified and they're 15 million years old, but they looks like they've been transported. Here's the punchline. In the old days, in George Beck's time, this sediment was viewed as a lake sediment. And there was a lake that protected the logs. More evidence for that coming in a second. Current geologists working on this issue are revisiting the vantage and thinking there may be flows, there may be movement recorded in this. This is not just a layer of sand. These are volcanic mud flows, perhaps. These are debris flows. In fact, some of the latest work indicates that there are repeated units within this vantage horizon that indicate that there are flows of maybe more than 10 miles, maybe up to 50 or 60 miles. Now, why do we care about that? What's the connection to petrified wood? Are you doing the math? Maybe we got it. The working model is we've got this crazy variety of wood in vantage, let's say, because these trees were brought from different places, different locations, up in the foothills of the Cascades. And these individual pulses of flow coming from the Cascades are bringing these logs to central Washington. So here's one of the biggest messages I have for you from tonight. You go to Vantage, you see all these trees preserved in stone. Probably wasn't a forest right there. Probably was a collection of trees from different elevations up in the Cascades that were swept down by the volcanic mud flows and brought to this location and then dealt with the Ginkgo lava flow. So this is the latest attempt to work out the details of the story. A generation, 2 generations ago, it was detailing all this crazy variety in the wood. Now we're trying to work with the model of these horizons. It's more than the vantage sediment. On that stack of 300 lava flows, oftentimes there are little sedimentary deposits between eruptions of lava. So here's the way to view that. We got 300 lava flows, that's fine. Oh, is the first one Monday? And the second one is Tuesday? And these lava flows are coming in every day? No. Our interpretation is, because of these sedimentary packages between the lavas, there's thousands of years of nothing before the next eruption comes. Thousands of years of quiet, thousands of years of developing an ecosystem with plants and animals and streams and lakes, and then the next basalt lava comes in, buries everybody, kills damn near everything, preserves only a few of the trees in the pillow zone, but basically wipes the place flat of biology. But then you got another few thousand, maybe tens of thousands of quiet time to establish another ecosystem. That's why we have this repetitive story of different levels of petrified forest. Those ecosystems wouldn't give up. Lava flow wiped the place flat. We got time to establish something new. Okay, let's get right into this. Let's keep the momentum going and add visuals now to what we tried to establish. And I'll go through these quickly, and we'll get to a variety of concepts that hopefully will work for you. So, yes, you can go to the state park today. You can visit some of these logs. Young people in the room, take your family down there and enjoy these beautiful logs that are on display. You can go to the museum itself. There's a museum set right on the perch overlooking the Columbia River. There's also a trail of logs that are still in those basaltic layers. Here's an old photo. If you only know the vantage area since the 1960s, this looks foreign to you. But here's our visitor center and our museum, and we're looking south toward Sentinel Gap. And here's the floodplain of the mighty Columbia, now underwater, of course, with the construction of the Wanapum Dam. And it was back in the 1930s, most of you know, that the CCC was involved to create that state park. But there's a tie to the university here, then a college. And this gentleman here was the center of all of it, George Beck. His teaching career at Central from the mid-1920s to 1959. And he was a well-versed person. He was a musician, played his cello, sometimes in the teaching lab, and was involved in teaching music on campus and was in community music organizations as well. But his other passion was petrified wood. And he had a long history of being the resident expert of petrified wood in Central Washington. And he was the main guy to actually get this state park going and to convince people to protect these logs, to actually get some preservation. So today, some of the beautiful logs are out there in the state park. It is illegal to pick up petrified wood. It's illegal to mess with it much at all. And George was the guy to get that rolling. And thankfully, that's here for all of us to enjoy for generations to come. This is some of his early work. George Beck I'm talking about now. Back in the early 1930s, when he first started going out there, getting some tips from some locals, and starting to painstakingly go through these different logs, to identify them, to take good notes, and to ultimately come up with what I was giving you earlier tonight about our different layers and our different times. This is one of the logs that was beautifully preserved and photographed by Ashel Curtis. You know that name from lots of photography in the early days of Washington. So I like putting these lectures together for a number of reasons, including forcing myself to go through my file cabinets. And I went through a bunch of stuff I had collected over the years, and I found this journal, a copy of a journal that George Beck kept. If you can't read that from the back, this is a geology journal by George Beck from March 1st, 1933 to April 5th, 1936. So it's recording his daily excursions out to the vantage area, lots of it handwritten. He was a sketcher, he was a handwritten guy. I'm going to read just a little bit of this to you. August 28th, 1934, Beck, Ted Frechette, John Whitney, and a few others, down to the Columbia River north of the Frenchman Mountains. We started at 5 o'clock Friday morning, this is August now, going in Ted's truck and my car with supplies for a 5-day stay. We went by way of Guy Cook's place at the mouth of Park Creek and drove on in by way of the Quillamine to the Osborne Ranch. The first day, afternoon, we rested. It was awfully hot and hunted for water. Cook came in the afternoon and helped us open the pipe on the hillside that fed water to the house. It goes on, but it's a very personal narrative. It's almost a personal journal, as well as recording the geology. And he mentions Ted Frechette. Ted was Beck's right-hand man. As I understand it, Ted was involved in some of the teaching here at Central with Beck, but more importantly, Ted was a young guy, an eager guy, and he was installed as the main man to oversee the construction of the state park and be involved with the CCC. That's that same log again, by the way. This is a photo from 1934 and 1935. A quick personal letter from Beck to Ted. Dear Ted, I called Weigel, who's the state park superintendent, at his home right after we hung up and asked him about the situation. Blah, 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 blah. I'm tickled. Where is that? It tickles me pink to see you get a good job out of it. I told Weigel I thought you had it coming, and I do think so too. So between Beck and Frechette, there were great plans to establish this beautiful state park. telegram as well. This is all from the Frechette family. Ted's son Jim lives in Ellensburg now and has posted a lot of this on a website. I can send you the link if you like tomorrow when I recap this lecture. And there was a nice little article in the Ellensburg paper a couple of years ago about Jim, who's now an old man, reflecting on his dad, Ted. There's tragedy involved here. Ted died suddenly in 1935, long before much of this was constructed. It was a short illness, and Jim was a baby at the time. So Beck continued on without Ted's help, but they eventually got this thing established, and we all see it now, and we enjoy it. So, yes, grand opening or some sort of event here with all these beautiful cars from the old days. You've been to this place, perhaps, where the trees are caged in the hillside. Take the hike on a nice hot afternoon in August. Nothing better. So, archival photos of visitors who are still stopping and visiting. Well, here we go. Our logs coming right out of the basalt. Seems impossible to believe. But if we pause and really address these pillows, I think we can feel a little bit better about why these petrified logs are coming out of this lava. So these are the pillows in living color. Dark circles, this is a cowboy hat for scale, dark circles with our orangish, greenish, crumbly stuff around the outside. And here's a detail. 2 different pillows and some of this orangish, greenish material and some car keys for scale. For many, many years, this is what I used to teach my students about pillows. Onward we go. So, the next time you drive on the old Vantage Highway, maybe you knew that already. If you didn't, here's a beautiful set of pillows on top of a sedimentary bed. I'm not saying there's logs right there, but there are places where logs have been pulled right out of the pillow zone right on Interstate 90 as you climb from Vantage, heading up to Ryegrass. Climb from Vantage up to Ryegrass. You're heading west. Keep your eyes on the road. Have somebody next door, a shotgun, look for these holes occasionally. Some of these photos from Jack Powell. So the logs are pulled out. They're now on the ground at the museum for the visitors to enjoy, but quite often those logs are coming right out of the pillow zone. Another shot, right? Get the sense where that is. So you're maybe still wondering why the logs didn't burn up. We're still in the lava, so we got a little bit more work to do there. A little idea of the variety of the wood. I've already made this point, but you can look at the literature and realize that the list is endless, just crazy, crazy variety. And the idea then is that if we are involving these lahars, if we are involving this transportation agent getting all these logs together, we maybe did have a lake in the Vantage area with logs in the water. Again, the water's present, the logs are present, but they all aren't right there in a forest, right there at Vantage. That's the idea. Another nice cartoon from Powell talking about our lava flow coming in, preserving somehow these logs. That's the other 2-minute clip to try to help you answer that question. Here's our Vantage sediment and an older Columbia River basalt below that. The preservation is absolutely staggering. And if you haven't seen any of these pieces up close, please go down to the state park tomorrow. Or I've got some polished slabs up here on the stage that you're welcome to come up and look at after we're done. And that's just a few minutes from now, by the way. I've also got some other archival material that I'd like to share with you as well. Back to Beck then, so we'll sprinkle in more of his journal stuff. Maybe from the back of the room this is hard to see, but Beck is understanding that we have this folding. Beck understands that the layers are not flat and that it helps us understand how we can tie these petrified wood locations together. And Beck is doing what I did on the chalkboard. I'm just copying him, right? He's got all of his basalt lava flows. He's taking notes as to which horizons are yielding wood, which are yielding leaves, which are yielding fossils of critters. Not very many. That lava was so destructive that there was hardly any vertebrate fossils recorded. Also pretty light here, but a detailed hand-drawn sketch of the area north of Vantage. North is to the bottom here, but basically out in the state park that is now preserved by the park. And Beck was starting to wonder about this crazy variety. And he was trying to draw uplands and somehow get that material down. I'm not sure he was thinking lahars, though. He didn't have the benefit of seeing what happened with Mount St. Helens. And you know what that lahar looked like, right? You picture the Toutle River Valley in 1980 and this big slurry of mud. It wasn't really mud, though, right? It was rock and ash and debris and water with the strength of liquid concrete. That's what we're talking about coming out of the highlands and delivering these logs and picking them up as they go. This is one short clip from Trees of Stone, a short film that's been shown, every hour on the hour for years at the museum. A short little clip from it.
To the west, the Cascade Mountains stood much lower than they do today. Moisture from the Pacific Ocean crossed over the Cascades easily. The climate was warm and humid, the plant life thick and lush. Swamp trees flourished along the wet edges of lowland lakes and rivers, while broadleaf forests and cone-bearing trees covered the higher hills. Strange prehistoric animals made their home here too. Squat, short-legged rhinoceroses.
Well, some of you know there actually is a mold of a rhino from this time on the way up to Dry Falls at Blue Lake. So this is an old publication in the 1950s. Here's our friend George Beck taking Central students out to the Blue Lake Rhino. Here he is, kind of sitting here, dressed in his tie and his white shirt, and having the students go one by one up the ladder to check that out. So that is real. The Blue Lake Rhino is part of the story. I love this photo. She's like, you don't understand. I'm from Renton. I don't belong here. So I keep going back to his journal, and I think the timing is such that his journal is, at least this journal is from the early 30s, when he was really going full guns, going great guns with developing the park and going through these logs. I'm not sure he had that momentum going through his whole career, and we'll see how he transitioned in some other efforts. Here's how we get some of the detail of the actual wood types. You can actually just take a cut of a log. You can use a regular handheld camera, zoom in real tight on one of these polished slabs, for instance, and take a pattern of the structure of the cells. This is out of my area, but you can compare these cell patterns with living trees, and it's an open and shut case. You can make beautiful cases for the types of wood that are present. Also, from Trees of Stone.
Crystalline quartz may take millions of years. Laboratory research suggests that after the silica enters the wood, it bonds itself to cell walls first, and then fills the space inside them. Gradually, the grain of the wood is recreated in stone. The best examples of petrified wood, like these uncovered at Vantage, show every growth ring and resin duct, every crack and tiny detail of the original wood. The tissue structure is so well preserved that several million years later, Professor Beck was able to tell what types of ancient trees had been trapped in the lava flow.
The ginkgo leaves are part of the story, and they were the prized possession that Beck was looking for. Another clip, short.
At least 6,000 years ago, humans in central Washington were fashioning blades and weapon points from stone that was glossy and hard as flint, but looked like the wood of a tree. When Professor Beck and his students unearthed the petrified forest, they were actually hunting for one specific type of petrified wood. Fossil leaf prints of the ginkgo tree had been found in nearby Grand Coulee, but the fossilized wood of the ginkgo had never been found by anyone anywhere in the world. The stately ginkgo, with leaves like fluttering paper fans, is one of the oldest, most primitive trees still growing on the earth. 200 million years ago, during the time of the dinosaurs, ginkgo trees flourished in temperate regions all around the globe.
Another classic old photo from a place on the northern edge of Ginkgo State Park, where one of these logs is actually standing. Some dogs here in the shade. I don't have a date here for the photo, but it's pretty sweet. The slabs I have up here were donated to the geology department here at Central from Audie Turner and his wife. They ran a rock shop in Yakima. And Turner was one of Beck's hunting buddies, hunting for petrified wood. There was a number of these amateur guys who were totally into it. And I suppose Audie's not an amateur. He ran a rock shop. But we've got more than 200 of these polished slabs, many of them on display in Lind Hall, where our geology building is located. And also in that display are more treasure maps on where to find these logs and where Turner was collecting his work. This is in a publication called Gems and Minerals. This is, here's the footbridge at Umtanum. So we're in that Umtanum petrified forest layer. Audie's handwritten notes about his locations. Another publication by a fellow named Jackson. More treasure maps for people. This is outside of the state park boundary at Vantage. This is a little way to get to the logs up at Saddle Mountain. So this is not just a couple of people. As you heard from Chuck and others, there's a whole generation of people who really were just obsessed with this petrified wood business, and there was tremendous amounts of collecting and trading and everything else. So this is one of our last photos. Do you recognize it? Jack Powell was talking about it during his little story. This is a photo taken by the late Marty Katz, taken in 1970 as Interstate 82 was being put across Menashtash Ridge. Cut into the ridge, here's our Vantage sediment. Used to be flat, now almost vertical. This is the unit then that Bentley and others are reinterpreting as a dozen separate little debris flows that are carrying material instead of just settling out the bottom of a lake. So you get confirmation then what's going on. Few more. Here's a cartoon. Beck must have been beloved. He's got students making cartoons of him. He's got political cartoons and other things about going out and collecting. And this is a twist I was surprised to find. Somehow our department got a bunch of letters that were sent to Joe Doby in Yakima. And the letters were from the Fossil Woods of the Far West group. That was Beck. Beck was handwriting newsletters and drawing cross-sections of his cell identifications. And for a small charge, was sending photographs through his microscope. And was sending to these people who had this amateur interest, I presume. But by God, he had his own letterhead, for goodness sake. So whether it was just truly public outreach or whether it was some other kind of approach, that was part of Beck, especially later on. This is another one of his kind of hand-drawn newsletters back in the early 1940s. Just spreading the word, just helping people understand about all these logs. And I've got some of those letters with me, the Joe Doby letters, if you want to see them up close. Yes, Beck did some official publications as well, but for the most part, he stayed local. There is a guy, though, an amateur, Tad Dilhoff, who lives now in Issaquah, who has been very into petrified wood and has been linking up with geologists and formally studying the woods of the Ginkgo horizon. And Tad's a wonderful fellow, has been a good friend to our department, and I'm happy to report then that there are people still working on this. This is not just Beck and his cronies 70 years ago and nobody working on it today. So there still is work being done. In fact, Tad has a website called evolvingearth.org, which is he and his brother supporting student work and also trying to just continue the work of Beck and others a generation or two ago. A couple finals. After Beck retired in 1959, he returned to Yakima, was heavily involved in the Yakima Museum. This is from 1965. The last thing I was able to find, 1979, the dedication of the George Beck marker, which you maybe don't know about, but I think you do. You recognize this? You're driving down the Yakima Canyon and there's a brown sign, a heritage marker up ahead. That was dedicated to George Beck. And if you stop, I mean the tourists stop, but if you stop, you can read a little bio on George Beck. It's kind of weird, it's in the canyon instead of down at Vantage, but anyway, it's there, and there is a living monument to George and his work. So here's the star of the show, George Beck. The petrified wood is the star of the show, and I'm hoping that you feel like you have a better feeling for all of these buried forests in central Washington. Thank you for coming out tonight. I appreciate it.